In this lesson, I'm going to show you how to create mates within an assembly, use advanced mates, configurations, and appearances. So first, we have 3 parts here that have been created. Let's have a look at the parts. To do that, I'm going to go ahead and create a new assembly. So new assembly, okay. And there are 3 parts that are open right now. Those are the ones that it thinks I would use: housing, piston, and cap. I'm going to click on housing, and instead of just placing it anywhere in the view, I'm going to click on the check mark so I place it at the origin. So it's there now, placed at the origin. Next thing I want to do is I want to insert the cap. The cap looks like it's just the top of the cylinder, so I'll just click up here to place it. And now let's make some mates. So click the mate button, and if I zoom in, I'm going to click the inside surface here of that cylinder and the inside surface of this cylinder, and it does an axis-on-axis rotation. Now, one thing it does is it offers me the lock rotation check mark. If I click this, it'll not allow the part to rotate anymore, which in this case is beneficial. I'm not going to do that, but I recommend clicking this lock rotation if you have round parts that are symmetric. I'm going to show you another way in case there's some reason you need to align it a different way. So I'm going to go ahead and leave it unchecked for now and click OK. And I'm going to get out of the mate command, so I'll hit escape, and the only thing left that this part can do is it can move up and down, and it's hard to see, but it can rotate around the axis as well. So let's create a mate. I want this face on top here, top face of the housing, to be coincident with the bottom face of the cap, so I'll click a check mark for that. And then the last thing I need to do is to lock the rotation down. So what I'm going to do is I'm going to choose, let's see, any plane that's not perpendicular to the rotation. So this right plane will do, and I'm going to choose the parallel constraint, and I'll choose the right plane of the assembly. So by clicking that, it's going to rotate around so the 2 right planes align, and I'll click a check mark, and this will finish the design, so finish the constraints. Notice there is not a minus sign next to cap 1, so it is fully constrained. And like I said, you could have used the lock rotation if it didn't matter what orientation you want, but this way it's now fully defined. Alright, so there's the cap of our cylinder. We have a housing and we have a cap. Let's insert the 3rd part. The 3rd part will be the piston. And we're going to insert it here. Alright, so there's a lot of different ways. The first thing that I want to do is just line up the axes. So I can do a mate and do axis with the axis of that inside surface, and click check mark. And that's fine. Hit escape to get out of the mate command. I still have the freedom to move. The problem with it is I don't really have any way of controlling when or how it's stopping. So let's see, I'm going to go back into this mates. So by opening up the piston, I can see the mates that are in this particular assembly. Matter of fact, let me save this assembly. It's going to rebuild and save. And it's under a folder called cylinder, so I'll name it what it's under. So save it under a cylinder. Okay, by selecting the housing and right-clicking, one of the options is change the transparency. So I'm going to change the transparency there. And that's going to allow me to look through the part. Now, one of the nice things about this is now when I move, I just, as default, I'll grab the inside and not the outside. One of the disadvantages is really the same thing, that if, for instance, if the cylinder is located somewhere around the edge of the thing that's transparent, it's almost impossible for me to grab the transparent edge. So a couple things to note about that. We're going to go ahead and make a mate. And I think what I want to do here is make the cylinder capable of moving, but not allow it to move outside of the realm of the cylinder, like the real piston would be. So what we're going to do This is an advanced. This is a mechanical mate. No. This is an advanced mate. This type of mate is called a distance mate, so I'll click on the distance button. And let's delete anything that we have selected so far. What I'll do is I'm going to select this top face and the bottom face of the cap. Be okay. And it can go anywhere from 0 to 6 inches. So let's click the check mark and see what happens. It can come up until it stops. Notice I'm trying to drive it up higher, but it won't let me. And it can go down until it hits the 6-inch mark, and then it doesn't let me to go any further down. So let's go ahead and change that distance. So I'll click the check mark. I'm finished with the mate command. We'll go back into the mates, and that last one, that limit distance, let's edit it. Looks like maybe 8 inches would be closer. So check mark. Check mark. Got me a little closer. Maybe it's 10. And this time, instead of leaving it, I'm going to put it currently at 10. Let's see what that looks like. 10 is a little too far. We've actually interfered with the bottom. So what we'll do is 9.75. So it's 1/4 of an inch thick, so 9.75. And check mark. And now my limit distance, I cannot drive it outside of the bottom. This is really useful for me. Click the check mark, and we'll click save. Rebuild the document and save. Notice the piston can still rotate. The reason it can rotate is because the concentric right here, it still has the ability to rotate around. So now I'm going to go ahead and lock the rotation and click the check mark. And I did that so that we could see that the piston is fully constrained. There's no minus sign next to it, even though it has some motion, because we've controlled the motion. So this is important. Now, a lot of times when I'm designing, this cylinder, for instance, might have a purpose in which sometimes it's fully in, and maybe we need to check clearance. Other times it's fully out, and then the time in between it might be driving something, we need to see what's going on. So a lot of times I would want 3 different states: in, out, and available to move. So to do that, we're going to do something called configurations. So one of the tabs here in the model view is the configuration manager. And so right-clicking on cylinder configurations, I'm going to create 2 new configurations. Add configuration. I'll call this one up. And I'm going to do it again. I'm going to go back to the cylinder configuration and add configuration. I'm going to call this one down. And my goal is to have some constraints up and down. Okay. And then default, by single clicking, I can rename the default as free. This is the one that I currently am on, where I can move it around. Okay. So now that I have those configurations created, and free is the one that I'm currently in, let me go back to the feature manager design tree, and I'm going to look at the mates, and the mates under piston, and this limit distance, this is the one that makes it free. Right click on this one, and instead of editing the feature, I'm going to configure the feature. So I get this pop-up that asks me, when should I use this particular function? And I only want to use this when I'm in the free constraint. So I'm going to suppress it when it's in down and suppress it when it's in up. Click apply and OK. And I'll show you what that does. Going back to configuration, if I move it in the down configuration and come back here, the piston is now no longer fully constrained, and I can move it however I want to. So while we're in this configuration, let's go ahead and make it be fully defined again. I'm going to click the mate, and I'm going to click just a distance this time, so distance, and right now I'll do 9.75. That's what we decided was all the way down, and between the faces up here at the top, so this top face and the top of the piston, and this is the down position. So I'll click a check mark. Okay. And now looking at these mates, I now have two mates that both are affecting the same thing. The limit distance allows it to move, and the regular distance keeps it locked. So right-clicking on regular distance now, I'm going to go back to configure feature, and I can see that it's been suppressed for free and up automatically. Now I'm going to unsuppress it for up, and what I want to do is by putting the drop down, I can see I actually have other things that I can open. So for instance, D1, click the check mark for D1, is 9.75. If I want it to be up, I want this distance to be 0. So I'll click apply, and OK. So what we've now done is, looking at the configurations, when I'm in the down position it cannot move. When I'm in the up position it moves to the top and it cannot move. And in the free position, it's allowed to move back and forth. All of these are fully defined, and all of these are controlled by configurations. One other configuration that's very useful is the exploded view. And the exploded view is found just directly within the Assembly tab. There is an exploded view button. I'll click that button, and it's going to ask me what do I want to explode. And I'll click in the order of the way things ought to be removed. So one, first one, I'm going to want to remove it this upward direction. And after that, let's move it in this outward direction. Then after that, we're going to bring the cylinder, the piston, up. So basically what I'm doing is I'm taking the part apart. So those three are enough for now, so I'll click the check mark. So looking in, we've exploded the free configuration, so underneath the free configuration is now the exploded view configuration. So if I double click here, there's the exploded view. You can look at each step along the way. So I can see it when it's put together, and I can see it when it's apart. So that gives us a brief introduction into configurations and explodes, and also how to make a part be clear while it's in the assembly, or transparent while it's in the assembly.